I got married. It was a wonderful time. It was a super small wedding, so we just had the basics. A ceremony, a dance, some desserts, and a fully customized version of the New York Times Games App that we modified to feature puzzles about us on our big day. You know, the basics. And obviously you know which of those we're here to talk about today. So the key to a good creme brulee is all about heat management. I'm kidding. What is this? Well, if you haven't seen the normal New York Times Games app, it features a bunch of daily puzzles like the crossword, connections, the Wordle. You remember the Wordle, right? They're really fun. My wife and I play a series of these every day, including the LinkedIn ones now that those are out. And so do a bunch of my family members. We sometimes play in person together. We have a group chat to send scores back and forth, that sort of thing. But back to the wedding. We rented a huge Airbnb in the mountains so that our families could stay together for the entire day. And just a couple weeks before the wedding, my fiance and I were sitting down trying to think through what our families would be doing throughout that day. And we're like, well, they'll start with the daily little games, of course. And then naturally, we stopped and thought, could we make those wedding themed? And there's a really important point here to address, which is obviously there's an easier way to do this. There are websites where you can enter your own puzzle information and create your own crossword or connections or whatever you want. And those are actually a pretty fun way to try your hand at these. I actually recommend it. But there were 3 reasons for not doing that. 1, the New York Times had just come out with a new game called Strands, which we really enjoyed, but was so new that as best as I could tell, there wasn't an existing version of this where you could just create your own puzzle. 2 is just because of who I am as a person. Like, I like reverse engineering iOS things. Modifying an app like this is a way to make a wedding like a little more mine. And 3rd, we wanted it to feel just for a little bit like real life had faded away and the world had transformed into wedding day. And that doesn't mean go to these 4 different ad-ridden sites and do these little puzzles. It means that you open the New York Times Games app that you're used to, that you open every morning, and that it also is magically part of this transformation. So that's why we really like the idea of finding a way to actually plug these puzzles into the app itself. But also, like, how do you do that? Well, we have an advantage on our side, which is that these puzzles change every day. That means they're almost definitely not hard-coded into the app. They're probably fetched via some API. We can confirm this pretty easily using a proxy app like Charles. We've seen Charles on this channel before, but as a reminder, this sort of app allows us to capture HTTP traffic going in and out of the phone. If we launch the app, we should see a ton of traffic come in. And if we click through some of these, we can see that there's requests being made to these JSON files, and it looks like these JSON files contain information for each individual puzzle. So perfect. That means we might not have to dive into the app code very much. We just need to figure out where these requests are made and find a way to intercept them to return our own puzzle data. Let's look a little bit more into that. If I go and choose, say, the mini crossword, and I look at today's, I can see this clue, Senegal's neighbor to the east. So what I can do now is back in Charles, I'm going to click on the request list and I should be able to search for Senegal. And we can see that there's exactly one request that matched. I can double click here to go to it. We can see it's a request to svc/crossword/v2/puzzle and then some sort of ID. And if I take this response here and copy it out to Sublime so that we can read it a bit more easily, we can see that this does include the clue information for today's mini crossword, Senegal's neighbor to the east. And it looks like the next clue should be blank Alan White, which it is. Okay, but how did we know we wanted to make a request to this URL, to 22194? Where did that ID come from? I can do another search through the responses we've gotten so far, because I assume we make one call first to actually get what today's puzzle ID is, and then we make a second call to get that puzzle's contents. And oh, this looks exactly like what we want. This is a call to active.json, and it passes in the current date. And same thing as before, I'm just going to go ahead and copy this out to Sublime. And okay, it looks like this responds with the IDs for the current crossword, maybe actually going back a couple different days, along with the mini crossword, spelling bee, Wordle. Perfect. So now we know the flow for how the app actually fetches these puzzles. First, it's going to make a call to active.json and pass in the current day. And then for each of the puzzle IDs that are returned, it's going to make a separate call to fetch the actual puzzle's contents. So our goal is to find a way to hook into this call and have it return something else. Now, there's a couple ways we can do that. For one, we could do it on the network itself, like off device. Proxy apps like this often have a way to say, hey, whenever I get a request to something like this, return this hard-coded JSON instead. In Charles's case, you can right click on a request and choose map local. And this brings up a menu that lets you say, anytime this path is requested, return this JSON file instead. You can get even more advanced than that too. Something like that would be fine, but it would require us to go and hook everybody's phone up through a proxy like this and like change their network settings and trust a root certificate. It wouldn't be ideal. Instead of that, we can try to find where in the app this request is made and maybe hook in there. But having tried this before, when set this up the first time, I can tell you that's also going to be a tricky option. Because if you take a decrypted copy of the New York Times Games app, which you can get from a jailbroken device or just find it online, and if we take that IPA and convert it to a zip so that we can open it, we can then start to look for where that request is made somewhere within this application. And my favorite way to do that, which always feels silly but works, is to go to the terminal and just grep for one of the strings we're interested in. I'm using ripgrep here to make things go faster, and -- binary to say we also want to look in binary files. And we can see there's one result which is in a framework called staticdependencies.framework. And what we can do now is open a decompiler like Hopper, and I'm going to go back to Finder and find our staticdependencies.framework. I'm just going to take the binary file for this framework and I'm going to drag it into Hopper. And it'll take a second to load. Maybe this is a good time to clean up some confetti. Nah. And once it's loaded, we can go up to the strings tab here, and I want to search for that active.json. And perfect, we can actually see the exact path that we saw in Charles. We're making a call to svc games v1 puzzles active.json. And I want to see if I can find whatever code path refers to this string, which I can do here by right-clicking and going references to. And there's a couple of them here. I'm going to take one of them, and I'm going to ask Hopper to try to show pseudocode for this method. But this pseudocode is mostly nonsense. Compared to the relatively clean disassembly and decompilation you can get from Objective-C, we can see that this is decompiling a Swift method. And of course, it's possible to reverse engineer Swift. We might actually have some of that on this channel soon, but it's a lot of work. You don't get a lot of things for free. If we look to see where this method is called, then not a lot jumps out here either in the method that's calling whatever is getting active.json. I don't think we're going to be able to get a lot here from just statically reversing this app. Of course, with enough time, anything's possible, but putting yourself in the shoes of your wedding is in a week or two, this isn't going to be the way to go. We can maybe get a bit further by hooking up a debugger to the app and then maybe trying to like trace around what's actually happening around the time where the string is accessed. But again, I'm going for speed here. So maybe we don't want to mess with the area that's making this call within the app, and we don't want to mess with the networking layer outside of the app. But what about somewhere in between those two layers? When the app makes a request like this to active.json or to load the individual puzzles, it's probably talking to something like NSURL session, which is responsible for then going and actually making that network call. And there's already an incredibly helpful way to hook into network calls like that, which is using a class called NSURLProtocol. If you haven't run into NSURLProtocol before, it is one of the coolest built-in classes on iOS. It has existed basically forever, and the root idea behind it is to let developers extend iOS's built-in networking functionalities. That comes in a bunch of forms, but the easiest to think of is probably URL schemes. When you try to make a request to a URL that starts with HTTP, iOS already knows how to handle that. If you ask for FTP, iOS knows how to handle that too. But there are a lot of other URL schemes, both official ones and unofficial ones, like S3, which can point to a specific resource on an Amazon S3 bucket. So let's say you had an iOS or macOS app that was trying to access an S3 URL. In fact, here, let's throw the getter command line tool for a second. Let's start by just making a basic request. So I'm going to create a URL pointing to anything. We can do example.com. And then I'm going to use URL session to create a data task for that URL. If we run the app now, we can see in the console, we print out the contents of example.com. Right, fair enough. But if I were to take that HTTPS URL that we were using as an example and instead put an S3 URL and then go ahead and rebuild and rerun, we can see down here in the console output that this is an unsupported URL, which makes sense. iOS doesn't know what an S3 bucket is. But that same S3 object, which is the index page for Bryce.co, you can also express using this HTTPS URL. And we can see that the actual source for that index page is returned now. So it's kind of possible to convert between the two, but let's say you have a giant app that might have URL sessions scattered throughout it. You might have like thousands of different call sites that do things like this. And now requirements change and you have a feature request to handle these S3 URLs throughout the app. You could go and try to find all the individual places where your app makes any networking request at all and run that URL through some transformation to get the HTTP version. But instead, it would be a lot easier to teach URL session how to handle these types of URLs. So that's the kind of thing that NSURLProtocol is usually used for. Like we can make a new class and I'm going to call it S3 URL protocol, and it's going to be a subclass of NSURLProtocol, or in Swift, just URL protocol. And there's only a couple things you need to do in a class like this. First, there's a static function called can_init, and there's two variants for this, one that can look at requests and one that can look at session tasks, but we can just do the request one. And the purpose of this method is to return whether or not your URL protocol knows how to handle a specific URL. So we're making this URL protocol to handle those S3 URLs, any URL that has S3 for the scheme. So I can just take that into account here. We can look at the request.url.scheme, and I'm just going to check if that's equal to the string S3. And if so, that means our URL protocol knows how to handle this URL. Now, the other thing we need to do is implement the actual handling for that URL. And we can do that using this start loading function. Wait, have I been zoomed out this whole time? Okay, well, we'll fix it in post. Anyways, what loading a URL means is kind of up to you as the person who's defining how to handle this URL. In our case, we have a pretty easy path, which is that we're going to be getting a URL like this, and we already know that we can somewhat translate that URL to one that starts with HTTPS. There's a bit of a catch here that for the HTTPS URL, you need to know the region of S3. Like Bryce.co is hosted in the AWS region US West 2. But like, let's say for our application, we're assuming that all of our S3 URLs are hosted in this one place. So we're going to receive a URL in this format, and we want to transform it into a URL with this format. So I'm going to start by getting that original URL, which every URL protocol object has this request property, which is whatever request we're trying to handle. So I'm going to just ask it for its URL. And once we have that, I'm going to create a new URL that's going to be in this format, starting with this prefix. Again, we're just assuming for the purposes of our app that US West 2 is going to be where all the S3 items are stored. So I'm going to take this prefix, and then after that prefix, I want to add the original URL's host. So in our case, that's going to be Bryce.co, and then also the original URL's path with original URL.path. So again, it's up to us to determine how we want to handle this URL. In our case, since we can convert it to a normal HTTPS URL, I'm just going to handle the rest of this like it was a normal request. So what I'm going to do is create a new data task, basically the same way that we had in our main.swift file. And I'm going to make the request to that new URL we created. We'll get our parameters here. If we have an error, we'll deal with that in a second. But let's say we actually have data. What we need to do then is tell the URL protocol that we've received that data. And we do that by using this property called client, which is a URL protocol client. It's basically the way that once we have data, we tell NSURLProtocol that we have it. So we've got our client. First, we're going to tell it that we received a response at all. And that takes a couple parameters. The first is which URL protocol received the response, which in our case is us. So I'll just pass self. Then the response we received, we should have that right here. And then how we want to deal with caching. I'm just going to say to not allow caching for now. Next, we can tell it that we actually received data using this didLoad method. So again, we're going to pass self for the URL protocol, and then we're going to say that we got some data. And last but not least, we're going to tell the URL protocol that we have finished loading everything by calling didFinishLoading self. Error handling looks pretty similar. If we've received an error, we want to tell the URL protocol client about it. So did fail with error, we are the protocol that failed, and I'm going to pass in the error object right here. So that mostly looks good to me. The last thing we need to do is actually kick off that task. And now I think we're in a pretty good position. There are two other functions we need to implement though. We just implemented start loading. We also need to implement stop loading, which is if somebody tells this request that it needs to stop early, what should we do? Ideally, we'd go and cancel this data task, but for now, I'm just going to leave it. And then the other method we need to provide sounds a bit more interesting, which is this canonical request for URL request. And this has given us an opportunity to essentially dedupe requests that look effectively the same. Like for example, if the S3 URL protocol allowed for redundant slashes in places, and like these two requests were always going to go to the same place, then we could use this opportunity to remove any extra slashes from the URL and return a new request. And that way iOS would know that these two requests effectively mean the same thing, and it can treat them the same for purposes like caching. We don't really care about anything like that here though. So what I can do is just return whatever request was given to us and say that there's no kind of transformation logic there, meaning there's no special deduping there. We treat every different URL as a different URL. And now we're basically good to go. There's only one last small thing we need to do, which is if we go back here, remember that we're currently fetching this S3 URL. If I try to run this, nothing will change. We'll get the same error saying that this is an unsupported URL. And the reason for that is that iOS's networking system doesn't know anything about the URL protocol we just made. So what we can do is go to URLprotocol.register class. And this is what's going to let us pass in S3 URL protocol to specify that this is something that iOS's networking system should look at to figure out how to resolve URLs. And now if I rerun, we should see, there we go, the actual response to index.html just using this S3 URL. So this is super cool. We've taught iOS how to handle a brand new type of URL scheme. Now when we're running our apps, it can handle S3 the exact same way it can handle HTTP or HTTPS, basically anywhere in the system. Now the really cool thing about URL protocols is that they're a lot more dynamic than what we just did here. For one, we just transformed this into like a different networking request, but there's no rule saying that this actually has to hit that network at all. Like for instance, I could make another URL protocol called math URL protocol, and I'm just going to copy our S3 one over here. And I'm going to say that this one is going to handle any URL with the scheme math. And then down here in start loading, I'm going to get the original URL, which is going to look something like this. And I'm going to get this part of the URL, which should be the host. And then I'm going to use NSExpression to actually compute the result of that math. And then I'm going to convert that result double to a string. So now we've actually done math, but we need to tell the URL protocol about it. So just like before, I'm going to start by telling the URL protocol client that we have received a response. We'll pass in self for the URL protocol. We don't actually have a URL response to give though, and it's required. So I'm going to go ahead and create one using the URL response initializer. And I'm going to say that this is a URL response for our original URL that we get up here. And that is just a plain text response. The expected content length is going to be however long that string is. And we're going to say the data is going to be encoded in UTF-8. And so now down here, we can say that that's the response we're getting. And this time we can say always cache it because math doesn't change very frequently. Now, same as before, I'm going to say that we received some data, and that's just going to be the result string encoded with UTF-8 as we promised up here. And then we're going to say that our protocol finished loading. And now if we go back to main, now instead of fetching this S3 URL, we can instead fetch the results of 123 plus 456. And of course, we also are going to have to register our math protocol up here. But now if we run, let's see, we get 579.0. Cool. So we've written a URL protocol that can just do arbitrary math. Probably not perfectly. I bet division would trip it up for a couple reasons. But my main point is that NSURL protocol gives you a ton of flexibility. It's not just for like transforming one URL to another URL and making a network request. It is instead a way to teach the networking library how to arbitrarily handle any type of URL. And as part of being able to arbitrarily handle any URL, you can do a really cool thing, which is instead of just building a new type of scheme like this, you have the full flexibility to look at any part of this request to determine if your URL protocol should handle it. So for example, we could look at the path for the URL, and we can say that if our path is equal to some fixed string, like let's say foo, then our URL protocol can handle it. And for what it means to actually handle that URL, we could create any response we want, including just a very arbitrary one like hello world. Let's go ahead and encode this as data. Now I'm going to create an HTTP URL response very similarly to how we handled the math response. And I'm going to say this is a response to our request URL, that we got a status code of 200, that our HTTP version was 2.0, and that there weren't any interesting headers returned. And now let's go ahead and pass that information to the client. So same as before, we're going to say we received a URL response to self. Our URL response was response, which I spelled wrong. We're going to say don't cache. We're going to tell it we received this data, and then we are going to say that our request finished loading. And so what we're saying now is that any request whose path is foo, we're going to return hello world for. If we go back to main and register this one last URL protocol, if I make a request to example.com/bar, and let's go ahead and run that, we can see that we get an HTML page back from example.com, right? If I change that request to be to /foo, we now get hello world. Even though example.com is a real live website, we have just retrained iOS's networking system to say that if you get any request to foo, just return with hello world. Which again, super cool. If I comment this out and rerun, we're going to get an actual website, but with that URL protocol registered, we instead have control over what data is changed. So this kind of mocking behavior is super useful for iOS development. Like it's common in automated testing frameworks to like mock responses to your API. There's systems that'll use this to observe network requests for debug purposes, but it's also clearly useful for our case. With this, we can look at requests to URLs that return puzzle information, and we can return our own puzzle data instead. That's the theory, at least. Let's double check that it actually works. So I'm going to create a new Xcode project, which will be a framework that we can inject into the New York Times Games app. I'm going to call it NYT Wedding Games, and we'll leave the language as Swift for now. We'll see how far we can get with that. And I'm going to start by making a new NSURL protocol subclass, just like the ones we made in that sample project. And I'm going to call it Proxy URL Protocol. So let's create the basic class. And same as before, we're going to implement can init with request. And first thing I'm going to do is just log that we got a request at all. I'm using nslog here to make life a little bit easier. We'll see why in a second. But I'm just going to log whatever URL we get here. And then after that, I'm just going to return false. So this URL protocol isn't going to do anything interesting in telling iOS how to actually handle requests. For now, what's going to happen is iOS is going to ask it, hey, can you handle a request? And when that happens, we're going to log the request we see and then see no. And what we should get then is a nice way to see all the requests being made to make sure that this setup is actually working. Now, of course, the other thing we need to do is actually register this protocol just like we did in the sample app. And so for that, I'll make an Objective-C class, and I'm just going to call it NYT Wedding Games Loader. We want it to be an Objective-C, otherwise looks good. And the reason for that is that here we can use the load method, which is going to run whenever this framework is actually loaded into memory. Swift doesn't exactly have an equivalent. And here we're just going to tell NSURLProtocol that we want to register a class, and we're going to use Proxy URL Protocol class. I expect we won't be able to actually access it yet, and that's because we need to both mark this class as public and mark it as visible from Objective-C. And then we're also going to need to import our Swift header here. And now it looks like everybody's happy. Cool, so now I'm going to go up to Product and Show Build folder in Finder. And under Products, I'm going to go ahead and find the path to this actual framework. And now I'm going to use sideloadly, which we've used on this channel before. One, I'm going to go back to where that IPA file was over here. We had temporarily renamed it to .zip. I'm going to rename it back to IPA. And I'm just going to drag that over to sideloadly to say that's the thing we want to install on our device. And then the main reason we're using sideloadly is under here in advanced options, it has this nice functionality to inject a framework into that app. So I'm going to enable that. I'm going to go to choose a framework, and then I'm just going to drag that framework folder over here and click open. And now we can see that's in the list of things to inject into this app. So now when we hit start, we can wait a second. And now if we go back to our phone screen, we can see that it's installing this update. And so now once we launch this, our URL protocol should be in use. But before we do, I'm going to open the console app, and I'm going to choose that iPhone and hit start streaming so we can see messages come in. And I'm going to go ahead and filter to our NYT Wedding Games kind of prefix that we added in this log here. And this is why we're using nslog, by the way. I believe with this setup, print won't appear in console, even if you have these include info messages and include debug messages on. You can use oslog, but oslog is separately annoying, so nslog is the way to go. Now, if we go back to our phone screen and actually launch the app, we can see it immediately crashes, and it's complaining that this NYT Weddings Games framework is built for iOS 17.4, and this is kind of an older phone. So that's okay. I'm going to hop back over the Xcode. I'm going to update this. We're not using anything particularly new. I'm just going to kick it back down to 15. That's on me. Okay, build succeeded. I'm going to go back to sideloadly, and I'm just going to hit start again. That's going to take the same path to the IPA, the same path to this framework, which we've just rebuilt. And now it looks like it's uploading. If we switch back over to the phone screen, we're installing the latest version. All right, let's try that again. Cool, we can see our canon inits coming in. There's requests being made to these config files, to crossword/oracle. There's only a couple requests though. We only see like maybe 10 made. Even when we go back to the home screen, there was only like 2 more that come in. So I don't think this is actually capturing every request right now. There's one thing that might be broken there, which is pretty easy to fix, which is if you look at URL session configurations docs, we can go and find, there's a property on here called protocol classes, an array of extra protocol subclasses that handle requests in a session. The default session configuration, the one you use if you don't try to change anything, respects any URL protocols that you've registered like this, using NSURLProtocol register class. But custom configurations don't. Instead, you need to explicitly specify those protocol classes in this protocol classes array. So the thinking is that what this app is probably doing is using some custom configuration somewhere, which means that our new protocol class isn't even looked at. So to fix that, I'm going to go back to Xcode, and I'm going to make a new Objective-C implementation file, and we're going to go ahead and swizzle NSURL session configuration. So we'll call it session configuration plus swizzle.m. And our goal here is to make it so that anytime a session configuration is created, we are automatically injecting our protocol class in there. So I'm going to create a new Objective-C category, and we're going to make that category on NSURL session configuration, and we'll call that category NYT Wedding Games Swizzle. So this is adding some new code into NSURL session configuration. And in particular, we're going to add another load method. So this is going to run automatically whenever the framework is loaded. So now we want to choose what method we want to replace. I think we're just going to try to swizzle the initializer of this class. If we go back to NSURL session configurations docs, usually you don't call init. It actually is deprecated. Instead, you call one of these class methods, default session or ephemeral session, and that's going to give you an object back. So we could swizzle both of those, but I'm assuming that they internally just call init. So I'm going to start by trying to swizzle init to see if that covers both cases. So we're going to swizzle init, and we're going to replace it with a new method that we'll call swizzled init, very original. So now those are basically the names of both those methods, but now we want to get the implementation of those methods, like where they actually live in memory. So we can do method. This doesn't know anything about method because we need to import Objective-C runtime. Now we can get our original method, and we can do that using class get instance method because this is an instance method. We're going to pass in that class object that we got earlier, which remember is just self, so that's going to be NSURL session configurations class. And then we're going to grab our original method. We're going to do the same for our swizzled method. Again, this is a fairly normal swizzling setup, but if you're not super used to swizzling, then any swizzling setup seems weird. We're basically trying to get the places in memory where these two methods exist. This is the original initializer for session configuration and this new initializer that doesn't exist yet. But we're getting where they live in memory, and then we can tell the Objective-C runtime to just swap them around, which means anytime somebody calls session configuration init, they're going to get swizzled init instead. And now what we want to do is actually implement swizzled init. And as always with swizzling, this looks a little inverted. This looks like it should recurse. But remember, we swapped the implementation. So now calling self-swizzled init is actually going to call the real initializer because we swapped them around right here. So if we were to just do this, everything should be basically back to normal. Oh, I should have passed the original selector and swizzled selector here. If anyone was watching this very confused, I hope that resolves some confusion. Okay, so this should behave basically the same as if we had done nothing at all. The only thing I'm going to do for now is I'm going to add another log statement. And let's just say that we swizzled the initializer for this class. And let's try just running that for now. So again, I'm going to rebuild. I'm going to come over to sideloadly, and I'm going to hit start. The other thing I'm going to want to do is over on our phone, I'm going to actually dismiss the app because otherwise sideloadly is never going to be able to install it. Cool, looks like this is installed. Let's go ahead and launch it again. So we see can init with requests coming in, but nothing else comes in. This means my bet that swizzling just init would be sufficient maybe isn't the case. So instead, let's go back to Chrome and we're going to find these two methods that we want to swizzle. Let's try this instead. Instead of swizzling init, I'm going to swizzle that default session configuration. Everything else looks pretty similar. The only other big difference is that these are no longer instance methods. So instead of class get instance method, I'm going to do get class method. And we have to update down here with that new method name, and we're going to change that to say that it's a class method. Otherwise, everything else here looks okay. So now instead of replacing init, we're replacing this default session configuration. I'm going to go ahead and log that that happened as well. And then let's do the same for the ephemeral session configuration. So I'm going to just make another one down here. And now we basically need a copy of this. I'm just going to suffix everything with 2. Please don't hate me. And then instead of the default session configuration, we are trying to swizzle the ephemeral one. Okay, so now we're swizzling 2 methods, very similar setup to before. Each time those methods are called, we're now going to get the original object by calling the original method. We're going to log something, and then we're going to return that object. So let's try this one more time. I'm going to go ahead and reinstall it with sideloadly. Cool, okay, the new app is installed. I'm gonna launch it. We're hoping for some more logs than before. Nice, okay, so now we have that swizzled NSURL session configuration. We can see we're actually making a bunch of them, possibly mostly defaults. Oh, here's an ephemeral one. So, okay, good thing that we swizzled both. All right, serves me right for trying to take a shortcut there. Now what we want to do before returning the instance, the whole point of this is so that we can modify instance.protocol classes, which Xcode knows nothing about because it doesn't know what type these instances are. So let me go ahead and give them an actual class here. So our whole goal is to modify protocol classes. I believe protocol classes can be nil, yes. So probably what we want to do is check if protocol classes is nil. And if so, we're just going to set this to an array containing one item, which is that proxy URL protocol class. So if we don't have any protocol classes currently, then we're going to set a class. That might be sufficient. The catch is that I don't know if either of these methods returns an instance that already has some protocol classes added, like maybe default ones provided by the system. So I'm also going to add an alternate path here, where if we already have some protocol classes, we're still going to take the same array with a single item in it, but this time I'm going to add more items afterwards. And those additional items are going to be whatever's currently in protocol classes. So that way, if there's no value here, we're just going to have an array that just contains our protocol class. And if there is a value, we're going to get an array that has our protocol class at the beginning plus whatever was in there before. And I'm just going to go ahead and copy that down here as well. This is a perfect opportunity to refactor things so that code isn't duplicated, but that can be future me's problem, I think. So went ahead and rebuild. Let's go ahead and start again. So again, the hope for this is that we're going to see a lot more of these can init with requests coming through. And then I'm going to come over here and launch the app, and we can see a lot more can init with requests. Perfect. So I think that was our issue. So I'm just going to take all these requests, and I'm going to go ahead and copy them out to Sublime, as always, just to make things a little bit easier to see. But if I search for active.json here, I don't see anything. And if I search for puzzle, which was the part of the URL that we'd seen when it was actually fetching the crossword contents, I don't see anything either. And it could well be that we need to do something to trigger that active check again. Like maybe I can go start a game and come back. Let's see if that works. So now if I look back in the console, there's active.json. So I think it was just cached from a previous attempt, but now it's trying to actually fetch again. The tricky part here is that even though that request is made to get the active list of puzzles, there is no request below it to actually fetch those puzzles. So I think what's happening there is that we're getting this JSON response for the current list of active puzzles, which again look like this. And then there's some system through which the app is saying, oh, I already know what the contents of puzzle 22095 looks like. I fetched that earlier. And this is kind of tricky because if this is using one of iOS's default caches, then there are some easy ways to clear it out. Like NSURL cache has a method on it you can use to clear everything in it. But much more likely is that this isn't just like a basic built-in HTTP cache. This is actually storing the results of this fetch into a database somewhere. And so probably we're checking with that database to see if we already have puzzle information. And that's much harder because that then means we'd have to go back and actually reverse engineer the app to figure out how that cache detection works and how we can work around it. But again, we're trying to build this a week or two before a wedding, so let's not do that. Of course, once this is all set up, once it's installed on somebody's phone for the first time, these aren't going to be cached either way. So we do have that one opportunity to swoop in and capture that request. Now, the easiest thing to do here is probably to delete the app each time we reinstall it, which should clear the cache. But having played around with this before, I can tell you that that works sometimes, but doesn't work consistently. I assume just because iOS has taken its time to clear out the cache data. I didn't really look into that a ton though, because we have another option available to us, which is that these puzzle IDs do not matter. right? Like this idea is important so that the app can go and fetch the puzzle contents from the New York Times API. But we're going to be skipping that anyways. We're going to be returning our own mock data. We don't care at all what the puzzle ID is. So my thinking is that we can capture this active.json request. We can return our own mock response to that, and that mock response can return a random puzzle ID. In fact, different puzzle IDs every time this API is called. And that way the app will always get an ID back that it's never seen, and it'll say, shoot, I need to request the contents of that puzzle. And then we can swoop in and intercept that. So let's go back to Xcode. I'm going to make a new class that's going to be responsible for changing the results of that active.json call. And let's call it active puzzles proxy. We're going to have a bunch of different types of calls like this that we want to replace. And so instead of making a new URL protocol for each one where we have to do all that work like create HTTP responses and like convert to and from NS data, I'm instead going to make a much simpler interface here that we can call proxy. And it's going to look pretty similar. We're going to have one function that determines whether or not we can handle a given request. So that will just take in a URL and return a bool. And then one function that's in charge of actually creating a response for that bool. And I'm going to have that one just return a string. Now we can go back to active puzzles proxy. It's going to conform to that new proxy protocol we just made. And let's create stubs for those two methods. And for our first case, we're just going to look for any URL whose path matches that active.json one we saw earlier. And then for the response, let's do this. I'm going to go back to Sublime, and we have that response from earlier. This is the one that we copied from Charles. I'm going to take this, I'm going to copy it, and then back in Xcode, I'm going to make a new file that is just an empty file, and we're going to use that as kind of a template. We'll call it activepuzzlestemplate.json, and I'll paste in here. Now, the whole point of this is that we want to change the puzzle IDs whenever this is called. So one way to do that would be to load this JSON template and then understand the JSON, parse through it, replace the puzzle IDs. I'm going to go the lazier way, as is the theme in this video, and I'm just going to replace all these puzzle IDs with this kind of fake token puzzle ID. So back in the actual proxy implementation, I'm going to load that JSON file, or rather that JSON template, now that it's not really valid JSON. So first we're going to determine what bundle to load it from, and that's going to be whatever bundle this class is in. We can't do bundle.main here because that's going to be the bundle for the app itself, whereas this is a framework that we're injecting to the app. So we need the bundle for our framework. And now we're going to get the path to that template by asking the bundle for the URL of the file named active puzzles template of type JSON. Now we are going to load that template's data, and it's complaining that I said string was going to be required, which in retrospect was a bad idea. So I'm going to go ahead and update our protocol to say that the return type is an optional string. Cool. Now I want to replace each instance of that puzzle ID text with a random number. So I'm going to convert that data to a string. And normally we could just do template string.replacing occurrences. And that's going to replace every occurrence of a string with another string. But that's not going to work well in our case because we want to replace each individual occurrence with its own individual unique replacement. So instead, maybe what we can do is get an array of all the ranges where that puzzle ID token exists. We can do template string.ranges, ranges of, and then that puzzle ID. Cool, so now we have all the ranges. Now what I want to do is take all those ranges and replace the contents with a random number. An important note there is that if we replace the first range and we change the length of the string while doing that, we're going to have a problem, which is that all the later ranges are going to be offset because they were computed before the replacement took place. To work around that, I'm going to reverse this list of ranges to make sure we replace the last one first, then the one before that. That way, if the length of the string changes, none of the prior ones will be affected. So for range in puzzle ID ranges, and then I'm going to take this result and just assign it back to template string. So this should replace all instances of puzzle ID with ABC. Let's create an actual random number and we'll put it in the range of 5 digits because that seemed to be what the puzzle ID lengths were already. And we'll use that as our replacement string. And then we should be good to go. So after this point, we can just return our template string. One other thing we can do just to make life a little bit easier is to actually print out that template string. That way we should be able to see what's happening within the console app. Cool, that looks good for the implementation here, but we still have to hook this up to the actual NSURL protocol. Right now, remember, all it does is in can init, it says, no, I can't handle that. So let's first make a new array that's going to contain all the proxy objects we have. Right now, there's only one type of proxy object, which is active puzzles proxy. But again, the goal is to add more in the future. Now in can init, what we can do is first get the URL we need, which same as our example URL protocols is just going to be based on request.url. Otherwise, we don't have much we can do here. And then we're going to loop through each of our proxies, and we're going to check if that proxy can handle the given URL. And if it can, we can return true from here. And let's also add another log to log which proxy is taking the request. Cool, so that should handle what we need for this can init method. We are also going to need our start loading method. And we'll start off by unwrapping the URL just like before. And we're going to need to loop through our proxies again to figure out which one it was that we could handle that URL. There's a way to pass state between these two, but it's kind of annoying and we don't need it here. We'll just find the proxy again. And once we find the correct proxy, we can ask it for its response for that URL. We can convert that response into data using response.data. We'll encode it as UTF-8. Just like before, we're going to create kind of a mock HTTP response to return to the URL protocol. So we're going to say this is a response to that URL. The status code was 200. HTTP version we'll do 2.0. And header fields I'll leave for nil as now. We'll see if that actually creates issues. So now we have kind of our mock HTTP response. Our last step, like before, is to tell the URL protocol that we've received some data. So I'm going to call client URL protocol. We're going to say that the URL protocol, which is us, did receive this HTTP response that we just created above. And we're going to say, please do not cache anything. Then we're going to tell the URL protocol again that we have received some data. And then we're going to say that we finished loading everything. Cool. And I'll force unwrap these to keep the compiler happy. Hopefully that ends up working okay. And then just like our other URL protocols, we are also going to have to override the stop loading function, which in our case, we'll just have it do nothing. These requests aren't even hitting the network, so there's basically no time between when they start and when they return either way. And then we're also going to need to override that canonical request function, where just like before, we can just return the current request. We don't actually need to try to dedupe any URLs that look similar. So I think this looks okay to me. Again, when a request comes in, it's going to go through this proxy URL protocol. That's going to look in its list of proxies to see if there's anything that can handle the given URL. If it can, we'll return true here. And then later down, we'll use that same proxy to return some mock data for that URL. So let's try it. I'm going to build back in Sideloadly. I'll hit run. And then on our phone screen, hopefully we should see it start to reinstall soon. And let's launch. Hopefully we see more data this time and also hopefully not a crash. Okay, so now we have using proxy and now we have returning active JSON data. Perfect. And we can see each puzzle ID here looks brand new because before they were all in a very consistent range. And I think starting with a 2. And so what I'm hoping now is if we look further down, there we go. We can see that the app is trying to make requests to these randomly generated puzzle IDs, all of which are presumably returning no data. I wonder actually if we go down to the mini and try to launch it, something went wrong because it tried to make this request and presumably the server 404'd. Awesome. So now we're in really good standing for replacing the crossword contents because now every time the app launches, we know that we're going to request some new crossword data. So now let's make a new proxy for that. I'm going to call it Crossword Proxy, and we will add it just under where Active Puzzles Proxy was. And we're going to take this implementation as a template. They're probably not going to be too different. So now we have Crossword Proxy. We're going to need a different URL. This URL is a little more interesting in that it can change. Like all these URLs have different IDs near the end. And so instead of a direct match like this, I'm going to use a regular expression where I'm going to take the part of the URL that's consistent. We can just start with that. And then I'm going to match one or more digits. And then that whole thing should end with .json. And then we want to say that that's a regular expression. So this is finding the range of any part of this path that matches that URL. If that range is non-nil, then we know we have a match. Down here, things are going to look pretty similar. Now we need an actual crossword puzzle to return with. So I'm going to go back to Sublime. We copied this one earlier, and I'm going to do the same thing where I'm going to make a new JSON file. And I'm just going to call this one crossword template.json. And we can paste in this contents from Sublime. This is going to look very similar, except in this case, we know this puzzle ID is now incorrect because we're going to be requesting kind of this random ID that's encoded in the URL. So I'm going to do the same thing as before, where we're going to know that we want to replace that. And let's also change one more thing here to make sure it actually works. Instead of this clue, Senegal's neighbor to the east that we saw earlier, let's change this to something else entirely. Like, if you're enjoying this, remember to like and subscribe. Don't do that yet though. Only do that if we can get it to show up in the app. But now we need to handle this puzzle ID replacement. So I'm going to go back to Crossword Proxy. What we did before is we returned a random integer value. But now what we want to do is grab whatever ID is encoded in that URL and use that instead. So we should be able to do that by looking at the URL that we're given and taking its last path component. In that case, that's going to be the puzzle ID.json. And I'm just going to split that based on that dot and take the first half. Cool. And now we can do a much simpler replacement because we don't need to replace every puzzle ID with a different one. In fact, anytime we see puzzle ID within this JSON template, we just want to use whatever we found in the URL. So we can get rid of all this, and instead we can say template string.replace, and we should just be able to say puzzle ID here, and we're replacing that with whatever puzzle ID we got in the URL. And I'm going to update this down here as well to say returning crossword data. Up here, we want to use the crossword template instead. I think everything else here looks good. Let's build one more time. I'm going to go ahead and clear out the console and install. And let's go back to our phone screen and launch one more time. Now, if we scroll down, we can start to see these using proxy calls. So we have returning active.json data. We have more down here though. Perfect. So we're saying using crossword proxy for this URL. That looks great. And if we scroll further down, we can see we're returning crossword data. That looks really good. And we've replaced that puzzle ID correctly. So now let's check if that actually worked. If we go down to the mini, something went wrong. Okay, that could be a couple things. If I had to hazard a guess at one thing that we really kind of just skirted over, it was in this proxy URL protocol for this HTTP response. I kind of assumed we were looking for 200. I assumed our HTTP version. I also assumed our header fields. If any of those are different from what the app is actually expecting, that could create an issue. So what we could do is go back to Charles and actually look at what some of these responses look like. And while this one isn't the exact same URL that we're mocking, hopefully it gives useful information. Like we can receive response code 200. That makes sense for this sort of thing. I wouldn't expect a different response code there. HTTP 2, that's good. We can click down here on headers to see what headers we got back. Any subset of these could be important. And the way we can figure out which ones are important is to take all of these headers, copy them over here. Some of these we might need to recalculate, like content length is going to depend on what we're returning. So we can copy all the headers here, see if the request succeeds then, and then narrow down from there which ones are actually needed by removing some and rerunning. We can do that, but before we try it, the main one that jumps out to me is this content type. That's one that I wouldn't be surprised if someone's getting upset that it's missing. So I'm going to go ahead and at least include that and try again. And now let's reopen and see how we did. Okay, so we can scroll down just like before and try the mini again. This looks better than before. Okay, so remember what we're hoping for is a new clue above the keyboard. If we hit play, I mean, I had to buy a whole confetti machine for the intro. I might as well get some good use out of it. Awesome. So now we have the ability to actually customize the crossword puzzle. If we look back at the JSON file that we have within Xcode now, we can see that it's a fairly straightforward format. There's all these different clues. They mark which boxes are the start and end. And then if we scroll all the way down, we can see an array saying which boxes should be white and which ones should be black. If we look back at the screen, we can see that these boxes on the corners are empty. So that corresponds to this 0 here, this 0 here, and these two at the bottom. And then we can see the individual letters that should go in the finished crossword. So I've actually just pasted in the puzzle data that we used for our wedding. I can also go up here and change the offer name to Bryce because I think I can claim credit for that one. If we rerun the app and scroll down to the menu, you can now see the exact same crossword we had for our wedding day, which is of course mostly themed around our cat named Beans. Here she is, the theme of the crossword puzzle. I'll page through the other clues here too in case you want to give it a go. But that's awesome. We've successfully replaced the entire crossword. Let's look at the connections next. Hopefully it shouldn't be much more of a challenge, given we now have the system that we can proxy whatever request we want to. We just need to figure out what request is responsible for the connections game board and replace it the same way we did for the crossword mini. So if I launch the connections and we look at all the requests made, we can see basically nothing. One request made to a tracking endpoint. So what's going on there? Well, you can notice a clear difference in the way the connections loads versus the way, say, the mini loads. The mini loads instantaneously, but connections has this activity indicator that appears, which makes me suspect this is probably implemented with a web view, unlike the native implementation of the crossword itself. NSURLProtocol works out of the box for UI web view, but given the fact that we don't see any requests come in, this probably isn't a UI web view. This is probably iOS's other embeddable web view class, WK WebView, which is a slightly more secure web view that operates outside the bounds of your normal app process. WK WebView does offer a way to add extra functionality the same way NSURLProtocol works through a different class, WK URL Scheme Handler. But the catch is that it's less powerful. The docs even note that it only applies when the web view runs into a custom URL scheme. So this wouldn't work for trying to capture and replace HTTP requests like we're doing now. Luckily, we have another option. There's a private class called WK Browsing Context Controller that has a method on it called Register Scheme for Custom Protocol. This trick has been floating around for years and I cannot figure out where it originated from, but if you call this method and pass in some URL scheme, the web view will now actually go through NSURLProtocol for calls to that scheme, and that includes if you pass in HTTP and HTTPS. Like here, let me show you. I'm going to create a new header, and we're going to declare that a class with this name exists and that it's a subclass of NSObject, and that it has one method, which is that register scheme for custom protocol we saw in that header file earlier. So creating this header makes it so that we can reference this class from our own code. We're only providing the interface. We're not providing the implementation. We're not creating this class. We're only saying it exists somewhere else. Now, if we go back to our code that runs when this framework loads, we should be able to import that new header we made, and then we can treat it just like it's a normal class. So we can call register scheme for custom protocol, and here I'm going to register the HTTP scheme, and right below that, we're going to do the exact same register HTTPS. So again, after calling this method, WK WebView should start to honor NSURL protocols for these two schemes, which is perfect. That's exactly what we need. So I'm going to go ahead and build again and install again. And just like before, I'm going to scroll down connections and I'm going to tap it, and hopefully we're going to see a lot more data come in. We do indeed. We can see now all these requests being made for all the contents of the web page. Like these are requesting JavaScript files, these are requesting fonts. And these requests should exist in Charles too. So I'm gonna go ahead and search for elevator. And here we go. We have a call to SVC connections v2. We actually have 10 here, but I think that's probably because I loaded the page 10 times while Charles was open. So somewhere in this console output, we should have a request that looks a lot like that URL. Here it is. So good. We can see that URL that is actually going through our URL protocol, even though we don't have anything set up currently to hook into it. While we're here, I'm gonna go into Charles and I'm going to grab the response body for this. And I'm gonna go ahead and paste it into Sublime just so we have it. The URL looks very similar to the one we're using for the mini. The only difference here is instead of a puzzle ID.json, we have a date.json. Given how similar these two look, I'm interested in refactoring this a little bit so that this isn't specific just to the crossword. The only parts that are specific to the crossword right now are the format of this URL that it says crosswords here, the template that we're using, and then kind of the suffix of the URL a little bit, where one contains a date and one contains a puzzle ID. But those are pretty small differences. So what I want to do is actually rename this to be puzzle proxy. And we're going to see if we can get this to handle basically any of our puzzle requests. And to do that, I'm going to have this take in a URL regular expression that we should match based on, like this bit here, and also the template that we should use. Let's call that template name. And I'm just going to store these two in some properties on this class, just like that. So now when we're creating this to match the crossword, I'm going to actually take this path and I'm going to cut it out. And over in proxy URL protocol, it should be complaining that this no longer exists. Yeah. Instead of creating a class that's specific to the crossword, we're just going to have this general puzzle proxy class. And here we can say that this instance should be for the crossword, where the crossword URL looks like this and the template we should use looks like that. And now if we go back to puzzle proxy, now we're going to use whatever regular expression this class was instantiated with. And same down here, instead of crossword template, we're going to use whatever our given template name was. That's two of our differences. And then the only remaining difference is that we want to be able to handle both the URL ending with a date and with a puzzle ID. And so I think what we can do, instead of assuming this is a puzzle ID down here, I'm just going to rename this to be file name. That's going to be either the puzzle ID or a date. Then I'm going to try to guess if it's a puzzle ID based on if it just contains numbers. So if the whole thing is composed only of digits, then we're going to assume the file name is a puzzle ID. And we can do the same replacement that we did down below, where we replace puzzle ID with whatever the file name was. Otherwise, let's assume that file name is a date, just like we have for this connections URL. And I'm going to go ahead and replace whatever puzzle date is with the file name. And let's also provide reasonable defaults either way, even if we don't have the information for like what the date or ID should be. So I'll put a date for puzzle date up here. And if we don't have a puzzle ID, I'm just going to say that the ID is a random number, same as before, where it's somewhere in the 5-digit range. So assuming all that works, the last thing we're going to need is a response for the connection. So I'm going to go and take this one that we copied from Charles earlier, and I'm going to make a new file over here called connections template. And here we're going to add that puzzle ID, and here we can add puzzle_date. And so what we're hoping should happen is that we're going to match this URL. We're going to extract the date from the end here. We're going to replace puzzle date with that date, and we're going to replace puzzle ID with a random number. And then of course, to make sure it actually works, we're going to replace some content here, like iOS, beats, Android every time. Okay, back here in proxy URL protocol, we have this crossword mini one, but now we actually need one for the connections. So that was to SVC connections v2, and then of course connections template. This time we're not looking for a single number, we're looking for a date in the form of 4 digits, 2 digits, 2 digits, .json looks perfect, let's build. Okay, and then launching the connections, again, we're hoping for some replaced words here. Yeah, that's some good progress. We have an oops, something went wrong screen. Let's look at puzzle proxy. This method ends with a log statement that I'm not seeing in the logs. So maybe one of these is returning nil. Is our connections template? Oh, looking at this connections template, it has a slightly different icon than the other ones. I wonder if I didn't give it an extension. I didn't give it an extension. Okay, let's name that .json, drag that back in. The icon's still wrong, but I'm assuming that things are better now. In our URL protocol, I'm also going to add a quick log for this case that we get no response back from the proxy. No response from proxy for URL. Let's try that. Build succeeded, so I'm going to go ahead and reinstall, and let's relaunch. So now if we open up the connections, we're hoping it actually loads, and we're hoping for some new words. iOS beats Android every time. So now we want to do similar for the strands, but luckily that should be pretty easy. I'm hoping it follows a very similar format to the other ones. If we load up the strands and we just quickly scan through some of these requests. Here we go. We have one to SVC strands v1, and it's also date based. Cool. So I'm going to take this payload from Charles, and I'm just going to change the contents of the game board so we can make sure it works. And of course the Wordle, which we'll have to guess to confirm. Nice. Okay, I think we did it. So with that, we're in a really good spot. We can go into the Wordle, Strands, Connections, or Mini and get a custom puzzle for each, which was the original goal for our wedding. Those are the 4 puzzles that we play the most. So I think our main goal is done here, but there's one other thing I want to look at, which is that even if the puzzles are changed, the actual app isn't exactly giving off wedding vibes. So let's take a look at replacing that. What I want to do is figure out what the name of this view controller is. And on a jailbroken device, we can just attach a debugger and ask. But we've actually made it this far without really needing any jailbroken functionality, so let's keep that train going. Instead, I'm going to use an open source framework called Flex, which I'm surprised we've made it this far on the channel without talking about. Flex is the super awesome framework that adds a bunch of debugging functionality right into the app itself. So super useful if you're not running on a jailbroken phone. I already have it downloaded. So inside Lily, I'm just going to add a framework and I'm going to go ahead and select it. And now we're injecting 2 frameworks. The framework we just built that's in charge of turning these games into wedding games, and the Flex framework right here. Now, there's one more thing we need to do, which is that we need to tell Flex that it should actually launch. And to do that, I'm going to go back to our loader class here. And just a second or so after the app is launched, I'm going to copy in this line from the README, Flex Manager, Shared Manager, Show Explorer, which should actually show the Flex menu. Now, since we don't depend directly on Flex, our framework doesn't know anything about it. It doesn't know this class exists. So I'm just going to wrap this in an NS class from string to say, find that class at runtime wherever it lives. And I'm also going to make a category on NS object up here to say that these 2 methods exist. And with that, we should be able to build and install again. But this time when the app launches, after a second or so, we should see a new menu appear. So this is Flex. It lets us see the entire view hierarchy. It also lets us select part of that view hierarchy and then see the context surrounding that view specifically. So 2 things jump out to me here. 1, this is a Swift UI view. And 2, right up here, we can see that it lives within crossword.homeViewController. So if this was a normal UI view, we might have some more options like changing label text and hiding certain views. But for a Swift UI view, that's going to be pretty hard at runtime. So what I'm going to do instead is basically create the UI I want from scratch. And by create, I mean copy over from the last time I did this. There's nothing super interesting here. There's a view that represents an individual game tile and then like a stack of those views. The preview actually shows it pretty well. The only catch is that it's referencing a font that's provided by the app itself, so we don't have that here. Everything else looks pretty good though. The one particularly interesting part here is what happens whenever any of these views are tapped. How do we actually bring up the page for the puzzle that was just tapped? Well, if we look back over at the contents of our IPA file over here, there's actually something that jumps out that's super helpful to us. It's this deeplinks.plist file. Over in terminal, we can use plutil, which is just a built-in utility for interacting with property list files, p for print, and I'm just going to drag that plist file onto here. And then I'm going to copy the results to my clipboard so that we can go ahead and look at them over here. And here we go. Here's a list of deep links. And you can see there's a deep link for the Wordle. There's a deep link for the Mini. There's a deep link for Connections. And there's one for Strands. So that's exactly what I'm using in this Swift UI view. Anytime one of these is tapped, we're just using a deep link to navigate to the appropriate section. We've got Connections, Strands, the Mini, and the Wordle. The one catch with the Mini is that it requires you to pass in a date. There's no Mini deep link that is just for the current day. Now, of course, the catch is how to actually get this into the app. And for that, I'm going to add just one more swizzle, which is going to be on UI View Controller. And this is the exact same swizzling setup we saw before, just this time we're swizzling UI View Controller, View Did Layout Subviews. There's definitely some more efficient ways we could do this that wouldn't interfere with every view controller's layout pass, but this works and is fast enough, so I don't think we really have to care. And here I'm going to call Home View Replacer, replace Home View if needed. Of course, that's not a class that exists yet, so let's add it. We're going to need it to be accessible from Objective-C because we're already using it from Objective-C. And then of course we can just add that method that we're already calling. Oh, and we probably want to pass in the view controller that we're currently looking at. We'll go ahead and pass that in here. Cool, so now we can actually implement this method. This is going to be called every time a view controller lays out its subviews, and it's going to pass in any random view controller here. So the first thing we want to do is check if it's that view controller class we were interested in. So first, I'm going to get a reference to that view controller class that we're looking for. Home view controller class equals NS class from string. And I'm just going to paste in that view controller class name we saw in Flex earlier. And then I also want to check if the view controller is a kind of that class. And if it's not, but some other view controller, we don't care at all about it. Now let's assume this is the first time this method is running for this home view controller. First time that view controller is laying out subviews. We're going to set this up the way we would embed Swift UI in any view controller, which is to make a UI hosting controller and pass in our Swift UI view as a root view. Now I'm going to add that as a child of our home view controller and do the same for their views. We're going to add constraints ourselves, pinning each of the sides of the child view to the parent view. And then last but not least, we will tell the hosting view that it moved to our home view controller. So now we're just doing kind of the normal process for adding a child view controller. And this looks good. The catch we have to watch out for is this is going to be called every time that home view controller lays out. And we really only want to run this once. So what I'm going to do then here is I'm going to add an extension on UI view controller that adds this new property called replacement home view controller. And that'll use Objective-C as associated objects to provide the implementation of that property. Basically just a way to add a property to an existing class. And now we can update our implementation up here. For one, when we create this new child view controller, we're going to update this new property on the parent view controller. And now up here, we can check if we already have that existing view controller by looking at that same property. And if so, we know that we've already added the view controller. We don't need to add another one below. But we don't know if it's still visible. We could have added it previously, and then the actual app code added more views on top of it. So I am going to tell the home view controller that it should bring that sub view to the front. And then I'm going to return early because we don't want to do the actual setup code below. So that was a lot, but if we build again, we're hoping to see a dramatically different home view here. Oh, absolutely beautiful. So here's the 4 games we care about with custom names and descriptions of each. This is super nice, and everything should still work, right? Like if we tap on the mini, no. Why does changing the home screen break our puzzle replacements? Well, this crossword hint down here, one might have the caption that moment when. I don't think we've seen that before. So if I go back to Charles and we search for that text, one might have the caption. We might get a hint. And this is the reason. This comes through a request to mini-date.json. That date is the same one I had in our replacement view in the deep link for the mini. Remember that the mini doesn't have a deep link for just the current date. You have to give it a date. So over here in the URL protocol, we're expecting the crossword to be in the format of a puzzleid.json. But when we switch to open it via deep link, it now comes in through a different URL. Luckily, that's a pretty easy fix in our case. Because we made things so generic, we can just add a new entry for the crossword. And for this one, if the URL matches mini dash and then a date, just copying the same format as the ones below, then we'll do the same replacement as before using this crossword template JSON file. The one other thing that we'll probably have to change is that we know that these puzzle requests are cached. So I'm gonna go ahead and switch this to a different day as well. We don't really need that to change every time now that the thing's working. We just need it to be replaced once, and then that replaced value can be cached. So we'll go ahead and reinstall the app. And this time, if we click on the mini, we're back to our custom one. Awesome. This is looking pretty good. Anything else we want to change? You know what? I have one quick one. You might have spotted it at the start of this video, which is a little detail that I think makes a huge difference. If we go back and flex here, I want to look at the implementation of this navigation bar. And if I tap on the info for this image view here, I want to look at what image it has. And it looks like it uses an image named Games Header Logo New Home. So if one last swizzle, this time on UI image view set image, if we find that image that's being used for the nav bar, based on looking at the image's debug description, that's the best way I know to find the original file name. If we find an image that matches that file name from the nav bar, I'm going to replace it with a slightly different image. Let's try that out. And now one last time, let's check out our fully customized app, now with a brand new, more appropriate nav bar. I think that's everything. Thank you so much for joining for this one. This was a really fun one. A huge thank you to the so many people that have subscribed since the last video. I am completely blown away. Thank you for making this all possible. But I should really get vacuuming. I'll see you for the next one.
How does it feel to be Bryce?
We're rolling, by the way. You're live.
Oh, I'm Bryce's wife.
Oh, are you in this?
Yeah.
Yeah, okay. Thank you for always supporting my hobbies.
Well, thank you for...
I thought you were gonna say, well, this one I don't.
You always clean up after them.
Oh yeah, don't you worry.